Okay, so you guys have been studying my examples in section 8.2, and I just wanted to come in here and point out a few things to you that will hopefully make this section a little bit easier as you work through your homework. The first thing that I want to make sure you're clear on is the difference between this test and the one that we talked about last class in section 8.1, because these are both tests that are used to test for the difference between the means of two populations. So these tests are going to look just like the ones we saw in our previous section as far as the setup goes, where we're comparing values of mu1 and mu2. So the difference is that this one is going to use a t-distribution rather than a standard normal. We call this a t-test rather than a z-test. The t-distribution is just a little bit wider than the standard normal distribution, so we'll have a slightly different rejection region. And we switch to the t-distribution when we do not know the variation in the populations. So you'll remember the z-test. We said the most important thing was we had to know the population standard deviations. And we said the only way to know that is if that information was given to us from previous studies. So what we're looking at here is our other option. So this is going to be used when the population standard deviations are not known. And another way of stating that is all we have access to is the standard deviation of our samples. All right, now, as far as your standardized test statistic here, you're going to have two cases. And so what you're going to look at here to determine which one you use, although you don't know the population variances, you do have to have some information to compare them. So you're going to look at two cases. One, when the amount of variation in the populations is roughly the same, variances are equal. And the other, when the amount of variation in the populations is very different, and those variances are not equal. And again, for right now, we don't have a test for this. We will later. So for right now, this is, again, information that's going to have to be given up front. Now, when the variances are not equal, which is what you're seeing right down here, this standardized test statistic is going to look just like the one that we did for the z-test. And you'll notice that right here with how the standard deviation is written. This is the exact same standard deviation that we calculated in the z-test. It's just using a sample standard deviation. However, when the variances are equal, when the amount of variation is the same, roughly, in the two populations, then we're going to calculate what's called a pooled estimate for the overall standard deviation. This kind of pulls together information from the two samples, but it's more of a weighted value based on sample size. And this is going to be a bit of a lengthier calculation. So you're actually seeing two parts here. All right, we're going to calculate this pooled estimate of the standard deviation, and then that has to be weighted based on this second part right here, which looks at the sample sizes. All right, so because this calculation is different, a little bit lengthy, in the first example, that's all I did was look at how this value would be calculated. And so you'll notice, using the same basic formula as we saw with the z-test, the first thing that I did here was just look at the difference between the two sample means. All right, and I pulled that information from here and from here. Then I went to my standard deviation and I said, okay, this is a case where the variances are equal. All right, when the population variances are equal, this is when we're using a pooled estimate of that standard deviation. And that's what you're seeing in my calculation right here. All right, so here's my formula. All right, that's what my formula looks like. And then I plugged in all my information based on the sample statistics. And I calculated a pooled estimate of the standard deviation at 0.1208. Now, pulling all of that together, All right, I took that difference between the sample means, I divided by standard deviation, and I got a standardized test statistic of negative 1.407. Now, it's important to understand where this number is coming from, and so I wanted you to see it calculated by hand one time. But it is a very lengthy calculation, and it does leave a lot of room for possible calculation errors. So this is going to be one place where I strongly recommend that you use technology to help you through that calculation. So if you have not seen this already, in StatCrunch, you're just going to go to your stat menu like you always do, but you're going to go to T-stats when the population standard deviation is unknown. This is to sample because we're comparing, and this is a case where we have the summary statistics. All right, now I'm going to go through and input my information from this problem. So my first sample mean was 0.345. My first sample standard deviation was 0.305, and my first sample size was 11. Now, the second sample that I'm comparing to has a mean of 0.515, a sample standard deviation of 0.215, and a sample size of 9. Now, notice that very next thing says calculation options, and is asking me, do I want to pool the variances? The default is not to do that. That's a case where the variances are not equal. Since this is a case where we were told population variances are equal, we're going to click that box right there to tell it we do want to pool the variances. All right, now, what I'm testing here, my claim was that mu1 was less than mu2, so I'm going to match up that alternative hypothesis, and then I'm going to hit compute. All right, and again, what we're looking for here is that t-stat value, and you'll notice that's the same thing that I just calculated using the formula, which is a value of negative 1.407. Now, when you use a t-distribution, which like I said is just a slightly wider bell-shaped curve, you do have degrees of freedom, like what we saw with the chi-squared distribution. And the degrees of freedom will also depend on whether or not your variances are equal. If they're equal, then again, the degrees of freedom are kind of pooled. It's n1 plus n2 minus 2. If the variances are not equal, or things stay separate, then we take the smaller degrees of freedom based on the smaller sample size. All right, and so I also showed you here, again, just that difference between the two and how to use the t-table. Again, you just want to make sure that you're careful about your degrees of freedom. So for part A, where the variances were equal, we kind of pulled the two sample sizes together, did more of a pooled value. For part B, where the variances were not equal, we just used the smaller sample size to get our degrees of freedom. Now, beyond that, this is going to look like any other hypothesis test. All right, so again, main differences from one test to another, how we get the rejection region and critical values, and how we calculate the standardized test statistic. So from here, I walked you through 2 examples, and you'll notice when it came time to calculate that standardized test statistic, especially in a case where the variances are equal, I went and pulled this straight from StatCrunch. Not that I couldn't have calculated it by hand, but this is that really lengthy formula. And so in that case, when I need to get a pooled value, I'm just going to take all my information, plug it into StatCrunch, and let it calculate that formula for me. Now, just to compare, the second example I gave you was a case where the variances were not equal. And so in that case, my standardized test statistic, again, this looks just like what we saw in the previous section with the z-test. All right, not a bad calculation there, one that you're used to seeing. This is not to say that you still couldn't use StatCrunch. It's just in this case, you would not want to pool your variances. Okay, so just to show you kind of a comparison here. All right, when I go to my stat menu and I go to T-stats, when I don't know the population standard deviation, to sample, again, because I'm comparing, and this is another case where I have the summary, not the actual data values. So just like I did before, I'm going to input the information from each group. So sample mean for the first group, sample standard deviation, and sample size. Same thing for the second group. And then again, right here, I get to do, I want to pool the variances. So since this is an example where the variances of the populations are not equal, I do not want to pool the variances. I want to keep everything separate. So I'm going to leave that box unchecked. This is a two-tailed test, so I'm going to leave that alternative hypothesis at not equal to, and I'm going to hit compute. And again, what I'm looking for is that T-stat, negative 4.633, which is the same thing that I got right here when I calculated my standardized test statistic using the formula for when the population variances are not equal. Okay, so I wanted you guys to go ahead and be able to work on this. This homework is not actually due until next Wednesday because I knew it was a longer section and it would take a little bit more time. But go ahead and work through this homework for section 8.2. Try to work through it before we meet for class on Tuesday. I'll talk about it a little bit at the start of class and I'll go over any questions. But we're going to be looking at the next section, section 8.3 then as well. So you don't want to wait. Okay, so go ahead and get started, work on this, at least do a good bit of practice, and we will go over questions and talk about section 8.3 next class as well.